Hi guys, welcome to Teacher Bet's channel. So today we are going to learn a brand new chapter, It's in chapter 5 and the title is Network in Graph Theory. It's a new topic in KSSM and you are the first one, the first batch of Form 4 that we learned about network in graph theory. Okay, what will you learn? Yes, you will learn about network. Look at here, how beautiful is the network around the globe. This is maybe the air transportation around the world. And of course, a picture speaks 1,000 words. That is most commonly used in phrases. But a graph speaks so much more than that. So today we're going to study about network in graph theory. So network is used to link objects in the same field based on its needs, and it is widely used in transportation, computer, business, and in neuroscience and much more, and also in gaming fields. So guys, you can see how important is this network in graph theory is. So let's get started. So for 5.1, under the title of network, we will first see what is the relationship between a network and a graph. Okay, we start with a graph. A graph is used to represent data, This one we all know that, and we used to draw graph, with simple lines and sometimes it's curve. But today we are going to learn about graph theory, So graph theory, what is it? Okay, look at this diagram here. It is a series of dots, Can you see 3 dots over there? Okay, a series of dots that is either linked or not linked to one another by lines, by lines. And each dot is known as a vertex, This one dot is named vertex. And the line here, the line that join the 2 vertices is known as an edge, edge here. This line is edge, this is vertex. And you heard me saying just now vertices, what's the difference? Vertex and vertices. You see here 2 vertices, a vertex. It's a simple grammar, That means vertices is the plural of vertex. Okay, so a graph is usually used to represent a certain network, and a network is part of a graph. And let's see an example, Actually, this above here is also tells you a network of graph, Okay, I want to give you example. What kind of network? Let's say Alan, Alan here is a good friend with Beverline, good friend. And also Alan also have another friend, let's say Selenia, Selena, good friend also. And then Alan also have a friend, this is quite close, maybe his girlfriend, Dorina. And they always contact each other. They have a network. Dorina knows Selena, and Selena knows Beverline. They are also good friends. Okay, Dorina also have a friend here, Evan. Okay, Evan. So that is the networking. And if you see here, Evan and Ellen, there is no relationship, yeah, no connection, maybe they are not networking, they are not communicating. I don't know why, but this is an example. So you can say that what is the vertex here? The vertex is individuals, yeah. How many individuals? There are 5, yeah, 5 individuals. And then what is the age here? What is the age? The age is, what do you call this connection? They are friends, right? They are friends, so it's a relation. So this is a very simple kind of network, graph network, yeah. Okay. We go to the next part, that is a few terms, yeah. Students, you have to know a few terms. First is graph, yeah. What is a graph? Okay, a graph is a set of ordered pairs, yeah. You can write like this: graph equal V, comma E. V is the vertex, E is the edge, yeah. So V, you can say V is the set of dots or vertices, and V you can represent it in a curly set, a curly bracket, yeah, V1, V2, V3, and E is the set of edges or lines linking each pair of vertices. That one you can the sets you can write like this one, yeah. And sometimes depends, you can write also like this. There are 2 methods, yeah. Okay, degree. The third one is you have to know what is the degree of the graph, yeah. So meaning degree is the number of edges that connect two vertices. The number of edges that connect two vertices. And you can actually calculate the sum of degrees, yeah? The sum of degrees. Here, the symbol is this one, sigma. Okay? And there is a formula given to you. If you want to find the sum of the graph, the formula is twice the number of edges, yeah. 2 times the number of edges, that means 2e here. So it's better if you can look at one example, yeah. Okay, this is a simple graph, yeah. Here it is a simple graph. A simple graph has no loops and no multiple edges, all straight lines here. We'll go on, we'll see later what loops and multiple edges, yeah. Okay. So for example 1, based on the simple graph given, determine the vertices, yeah, the vertices and the number of vertices, n v meaning the number of vertices. Okay, let's start. Okay, to determine the vertex, yeah, vertex will be, so you list down all the vertex that you see here, yeah, and you have to list down it using a curly bracket, yeah, curly bracket, and then you just write vertex 1, 2, 3, 4, 5, 6. Okay, and then the number of vertices you just calculate here: 1, 2, 3, 4, 5, 6. So 6. Okay, for B, the edges. What are the edges? So you have to list down a pair of like coordinate, yeah, because one edge here is a pair of two vertices. So you have to write it in like a coordinate form. 1, 2. Okay, that is one edge, and then 2, 3. Yeah, 2, 3, and then from here 3, 4, 4, 5, and then 5, 5, 6, and then the last one is 1, 5. Do we miss anything? Oh yes, we forgot 2, 4. 2, 4, yeah? Okay, we start again, yeah? So 1, 2, 1, 2, and then 1, 5, and then 2, 2, 3, 2, 4, 3, 4, 4, 5, and then 5, 5, 6. Okay, close the curly bracket. Okay, next, the number of edges, how many? You can count from here, you can count from here also. Yeah, 1, 2, 3, 4, 5, 6, 7. 7. And you can see here also 7. Yeah, 7 edges. Okay, go to C. The sum of degree, yeah, this one, the sum of degree. That means the sum of degree for the graph. So we write V here equal to times the edges. Okay, how many edges? 7. That means the degree is 14. Yeah, the degree is 14. Okay, there is another way. Yeah, how do you find the sum of degree? Yeah, without using the formula. Okay, how to do it? We have to do one by one. Yeah, the vertex one. We have to calculate the degree of every vertex. Okay, let's say this vertex number 1. So the degree of vertex number 1 is you just calculate how many edges. How many? 1, 2. So this is 2. Okay, for vertex number 2, okay, the degree for vertex number 2 is 1, 2, 3. So this is 3. And then for vertex number 3, you can see here how many? 1, 2. So the degree for vertex number 3 is 2. For number 4, how many lines here? How many edges? 3. Okay, for number 5, you can see here 1, 2, 3. 3. That's another method, yeah. And then for 6, degree of vertex 6, only 1. Yeah, only 1. So what you do, you total up all what you have calculated just now. Here, you total up. So the sum degree of the graph is 2 plus 3 plus 2 plus 3 plus 3 and plus 1. How many do you get? Also 14. Okay, there are 2 methods, yeah. Hope you get it. Okay class, we go to example 2 for a better understanding, yeah. Okay, let's see the question. State the number of vertices, edges, and the sum of degree for the following simple graph, yeah. So when you see number of vertices, that means the number of vertices. So you just count how many dots, how many vertex. Yes, 7. And then the number of edges, how many edges here? The lines here you can see 1, 2, 3, 4, 5, 6, 7. Okay, 7. And then the sum of degree of the graph is 2 times the edges. So 2 times 7. Answer is 14. So very easy. Yeah. Okay, for B, the number of vertices is how many dots? How many vertex? 7. 7 also. Yeah. The number of edges, 1, 2, 3, 4, 5, 6, 7, 8, 9. So 9. So the degree of the graph, degree of the simple graph is 2 times 9. So answer is 18. So you got it over there. So with this knowledge that you learn, yeah, from these 2 examples, I think you can do exercise, the first exercise of this chapter, yeah, 5.1a. It is in page 132, and oh no, it's not in 132, it is in 134. 134, yeah. I think you can do question number 1. Yeah. Try to do it, guys. And I trust you. You can do it. Come on.